This is my beginning algebra course. Today we're going to learn complex fractions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, this is a complex fraction, and the reason that we call it complex is because you see that the numerator is a fraction and the denominator is a fraction. So you have fractions within fractions in these problems. So whenever you have fractions within fractions, they're called complex fractions. And the reason they're called complex is because obviously they're a lot more complicated than normal fractions. So what we're going to do is we're going to simplify. We're going to make these fractions less complicated. Now, we learned in previous classes and courses that a division sign, you can just interpret the division sign as, or you can interpret the fraction sign, this fraction symbol, you can interpret that as a division symbol. So we're going to write 5/6 divided by 2/3 using the older division notation. So all I did was change this expression to this expression, and it's just a different way to write it. So again, the fraction symbol is or can be interpreted as a division symbol. Again, we learned that in previous classes and courses. So now, as you can see, all we're doing is just dividing fractions. So this is what we did in my arithmetic course. Or if you took some other arithmetic course, you already learned this. Or hopefully you learned it. You should have learned it if you took an arithmetic course. So we learned that when you divide fractions, you just change the division sign to multiplication and flip the divisor. So I just flipped this divisor. I didn't do anything to the dividend, but I flipped the divisor. And I changed the division sign to multiplication. And you can use parentheses for multiplication if you want, or you can use a dot. But I don't want you to use crosses because we're going to use crosses as variables in problems that we're going to do in this class. So now it just becomes a multiplication problem. So all we're doing is just multiplying fractions. So when you multiply fractions, you know that you just multiply the numerator straight across, so 5 times 3 is 15, and multiply the denominator straight across, so 6 times 2 is 12, and then just reduce those, divide both sides by 3, and you get 5/4, and that is the answer. So as you can see, we took this complex fraction and made it a lot simpler. So that's what we're going to be doing in this class. We're going to take complex fractions and simplify so that they are not complex fractions anymore. All right, so on to number 2. So again, we're going to treat this fraction sign as division. So I just changed that, and now we're dividing fractions. Again, you can always consider a fraction sign or symbol to be division. Now you might be wondering, well, why can't we just consider the fraction sign to be division? Well, you don't really need to think about that right now. We went over that in previous classes, and it's really just a coincidence when it comes to the definition of division and so on and so forth. But you can go back to my previous classes if you want to talk about why that is. But most students really don't know why that is, don't think about it, and most teachers don't think about it. So if you want to know why that is, we can talk about it later. But for now, just you always want to remember that a fraction sign means division. So now, again, we're going to flip the divisor and change to multiplication and just multiply straight across, and we get 56/36. So it looks like we got another improper fraction. Now we can just divide both sides by, let's see here. I don't think our multiplication facts are going to work on this one. So what we can do is we can just keep it in factored form, and that'll help us reduce. And the reason it'll help us reduce is because I know that I can divide both sides of 8/12 by 2. Actually, I can divide both sides by 4. And then I'll get 2/3. And then I just combine and I get 14 over 9. That's one way to do it. Another way to do it is I can factor 8 to 2 times 4 and 12 to 3 times 4, and then the 4's just cancel out. I don't want to confuse you by using all these different methods though, so you can do it however you want to do it. But the reason I'm trying to do these other methods is because 56 over 36 is not easy to reduce. You can divide both sides by 2 because they're both even numbers, and then you get 28 over 18, I believe. And then you can keep going, divide both sides by, divide both sides by 2 again, I guess, and you get 14 over 9, so on and so forth. So there's a lot of different ways to reduce, so just be aware. I'm going to try to stay away from this method just because I don't want to confuse you. Again, the whole purpose of this is just to help us factor, but if you don't want to do it that way, if you just want to take 56 over 36, divide both sides by 2 using your calculator, you can do it that way also. Alright, so it's time for you to try, but just keep in mind we have a negative number here, so keep that in mind, so our answer should be negative. Try number 3, and when you come back, we'll do it together. Alright, we're back. Change to the old division symbol. Multiply straight across, and you get negative 5 over 28. So on that one, we didn't have to reduce. So we got negative 5 over 28. Good job. Try number 4, and when you come back, we'll do it together. All right, we're back. And we have to use parentheses on this one because we have a negative here. You're not allowed to put a division sign next to a negative sign. That's not allowed in algebra notation. So if you forgot about that, that's okay. We're doing it now. So I'm just going to use parentheses because I already have parentheses. And you flip the divisor. So we're using parentheses for multiplication instead of a dot. Again, there's a lot of different ways to show multiplication. But I don't want you to use x's for multiplication. Alright, so then we just multiply straight across, and a negative times a negative is a positive, and we get 24 over 20, which reduces to 12 over 10. Actually, we can divide both sides by 4, and then we get 6 over 5. That would be the fastest way. So, again, we took a complex fraction and we simplified it. So, obviously, we'd much rather deal with this fraction than this crazy fraction here. So, if you got that answer, good job. Try number 5, and when you come back, we'll do it together. All right, we're back. I'm going to use a dot this time for multiplication. 4 times 6 is 24, and 5 times 15 is 75. That's not one of our multiplication facts on the bottom here, but I know I can divide both sides by 3, and then I get 8 over 25. But you can use your calculator if you don't want to divide 75 by 3. Again, if this goes beyond your multiplication facts that you have memorized, then just get your calculator. Don't complain about it. Just get your calculator. You're allowed to use a calculator when you're reducing stuff like that if you want to. Alright, just don't use a calculator with an algebra program on it because that would defeat the purpose of learning the algebra. So try number 6, and when you come back, we'll do it together. Alright, we're back. Be sure to put parentheses. Multiply straight across and you get negative 5 over 12. So if you got negative 5 over 12, good job. All right, so now we're going to variables. So we're just going to use the same method. We're going to change to the older division symbol. And flip the divisor, change to multiplication. Multiply straight across, 2 times 10 is 20. 5x times 3 is 15x. And then divide both sides by 5 and you get 4 over 3x. Whoops. So pretty much the same thing, it's just that we have letters. All right. So on to number 8. We'll do another one together before you try one on your own. So changing to the older division symbol that we used in arithmetic. And switch to multiplication. Flip the divisor. And just multiply straight across. I need to move that over to show my negative sign there. And so now all we have to do is just reduce that expression. So I'm going to go ahead and shrink this stuff so I have enough room. So the 2 and the 21 we can't really do much with. A squared over a is a. So again, you subtract the powers when you're reducing with power expressions. So 2 minus 1 is a to the first power. And 2 minus 1, b to the first power, but the b's are going to end up in the bottom because there's more b's in the bottom than in the top. All right, so on to number 9. Why don't you try number 9, and when you come back, we'll do it together. All right, we're back. And multiply straight across. And we're left with 2RT over 9. Again, you subtract the powers. 2 minus 1 gives you 1R, 2 minus 1 gives you 1T. And the T's are on the top because there are more T's in the top than in the bottom. So if you got that answer, good job. All right, try number 10, and when you come back, we'll do it together. All right, we're back. And multiply straight across. Whoops, that should be 12. 12y squared over 9. Divide both sides by 3, and you get 4y squared over 3. All right, try number 11. When you come back, we'll do it together. All right, we're back. Multiply straight across. And divide both of these numbers by 3. And let me shrink some of this stuff. "45 divided by 3 is 15, and you can get your calculator out if you don't believe me on that. 12 divided by 3 is 4. And the a's just disappear because the powers are the same, and then we just have one b in the bottom because there's more b's in the bottom than on the top, and 2 minus 1 is 1. So I've got 15 over 4b. Good job. All right, on to number 12. Try number 12. When you come back, we'll do it together. All right, we're back. We've got to use parentheses because, again, we're not allowed to put a negative right next to the division symbol. And we can just multiply straight across. Negative times a negative is a positive. 1 times r squared is r. 4rt times 3 is 12rt. And then r squared over r would just be r. So if you got that answer, good job. All right, so number 13, we have something a little different because now we have a binomial in the denominator of one of the fractions, but it's pretty much going to be the same situation. But let's do this together. So same procedure. And we can keep it in factored form. 3 times x is 3x. So we can keep it in factored form. X plus 2 times 7 is 7 times x plus 2. We can keep it in that form if we want, but I'm just going to go ahead and distribute the 7. So 7 times x plus 2 is 7x plus 14. So that's probably the form that you're going to see in the book, in the answers in your book. And be sure to check all your answers. So no big deal on that one. Why don't you try number 14? When you come back, we'll do it together. All right, we're back. And we're going to multiply 5 times x plus 4, which gives us 5x plus 20. And 2 times x is 2x. So if you got that answer, good job. All right, so let's do number 15 together because things are getting more complicated. Now we have binomials in the denominators of both those fractions. little smaller. So now we have to, let's see here. I think we're going to have to shrink this a little bit. So now it just becomes a multiplication problem. Now we already learned how to multiply fractions in this course. And remember, before you multiply straight across in this situation, you have to factor anything that you can factor. Now in the previous two problems we did, we couldn't factor anything. We couldn't factor x plus 4. We couldn't factor x or 5 or 2. There's nothing to factor. But in this problem, there's actually something that we can factor. So we're going to go ahead and rewrite the whole thing. But instead of this expression, we're going to factor out a y, a greatest common monomial, greatest common factor. And 5y squared plus 2y. That looks correct. And so now that we factored, you can see we have common factors, so we cancel out. We cancel out the green parts because there's a 5y plus 2 on the top and a 5y plus 2 on the bottom. Whenever you have something on the top and the bottom, it just cancels out. And then we just multiply straight across with the leftover parts. 6 times y is 6y, and 7 times, and remember, if there's nothing there, it's just considered to be 1. So that would be 7 times 1. We learned this in a previous class in this course. So that's the answer, 6y over 7. Now don't you agree that 6y over 7 is a lot simpler than all of this stuff here? That's why simplifying complex fractions is such a useful tool, because it makes things easier for us. All right, so in this expression, you're going to find that you can, let's see here, you're going to find that you can factor this expression here. So why don't you go ahead and try this problem, and remember you want to factor this expression, and I'm going to leave the other problem in the window so you can refer back to that, and when you come back we'll do it together. All right, we're back. So again, same procedure in the first steps. And now we have to factor. And we know that we can factor out a common factor here. We can factor out y, and we're left with y minus 7 over 4. And it looks like there's really only one thing that we can factor, or excuse me, that we can cancel. We can cancel these y's because there's a y on top and a y on the bottom. So those just disappear. And then we go ahead and multiply with the leftover parts. 3 times y plus, or y minus 7 is 3y minus 21. And then 4 times 1 is just 4. Now again, you can leave this in factored form. You can write it as 3 times y minus 7 over 4. You can do it that way also. But your textbook, it's pretty much a guarantee your textbook's going to write it in this form. So if you got that answer, good job. If you didn't get that answer, that's okay. We're going to do more of these problems. All right, so let's do 17 together. I think I'm going to have to shrink this a little bit. And we'll change to multiplication. All right, so now we're going to factor this expression. We can pull out a 2z squared. Whoops, that should be z minus 4. And now we have 1z minus 4 here, and we have 2z minus 4's here. So we're going to be left with 1z minus 4 in the top. And we'll just multiply straight across with the leftover part. So 2z times 2z squared is 4z cubed. So this is kind of strange because we have a binomial squared and a binomial to the first power. So because there's more z minus 4's in the top than in the bottom, the z minus 4's are going to end up in the top, and we just subtract the powers, 2 minus 1. But again, this is a strange problem because the base of the power expression is a binomial. But don't worry about that. I don't think I'm going to give you very many of those problems. Or you're not going to have very many of those problems in your homework, probably. So we'll rectangle that. All right, so why don't you try a problem like that? This one's going to be a little easier. And when you're done, we'll do it together. All right, we're back. Multiply straight. Or first of all, we got a factor. I almost jumped ahead there. And there's really only one thing we can cancel out. We can cancel out the z's. But also we can reduce the 4 and the 2. But I'm just going to go ahead and multiply straight across because I don't want to confuse you. And then we can reduce later. So 4 times 7. Again, the blue part just disappears at this point. 4 times 7 is 28, and then z plus 3 times 2 is just 2 times z plus 3. And I kept it in the factored form because we know we can reduce this. 28 over 2 would just be divide both sides by 2, and you get 14 over z plus 3, because this would just become 1, but you don't have to write 1. You can just leave it as z plus 3. So there's a lot going on there, but you're just going to have to get used to all those little details. That's what the practice is for. All right, so if you got that answer, good job. So now we're going to something a little different because now we have quadratic expressions. This is the first problem in this class where we have quadratic expressions, so let's do this one together. And now we're going to factor whatever we can factor, and of course the quadratic is what we can factor. So we need two pairs of parentheses with x and x, because it's x squared. And what two numbers multiply to negative 21 and add up to negative 4? We can ask that because there's no coefficient on the x squared, so this is really simple. So what two numbers multiply to negative 21 and add up to negative 4? That would obviously be negative 7 and positive 4. I'm going to shrink some of this stuff so I'm not so cramped in there. Actually, it should be, I'm sorry, it should be, did I put a 4? That should be 3. I'm sorry. I forget what I just wrote. Alright, so we factored it. And now we can just cancel as usual. We have x plus 3 on top and x plus 3 on the bottom. So we just make those disappear. And we have 2 times x minus 7 is 2x minus 14. And 5 times 1 is just 5. Again, you can just consider the canceled out parts to be 1. So again, all you have to do is just the normal algorithm here. But then if you have something you can factor, you need to factor everything that you can factor. And then cancel out and then multiply straight across. Because when you multiply fractions, you just multiply the numerators and multiply the denominators. We learned that in previous classes. So now you try. I'm going to leave this problem so you can see it there. Try number 20. When you come back, we'll do it together. All right, we're back. And let's see. So now we have to factor. And I'm just going to go down because I don't have much room left. So remember, you can go to the right with your equal sign, or you can go down, but not up or to the left. It's just like reading. You have to read to the right and down, not to the left or up. Four and 1, so I'm factoring that quadratic. And now you can see that we have x plus 1 on the top and the bottom, so those just disappear. And 2 times 1 is 2. And 3 times x plus 4 is 3x plus 12. So if you got that answer, good job. All right, so 21 is going to be the same type of situation. The only difference is now we have the difference of two squares. So you should know how to factor the difference of two squares because we've done that tons of times in this course. So why don't you try number 21, and when you come back, we'll do it together. All right, we're back. if you forgot how to factor the difference of two squares, we'll go ahead and do that now. Refresh your memory. And y squared minus 25, that would, you need to put two pairs of parentheses, and then we have y, and what number times itself equals 25? That would be 5, and you put a plus and a minus. So that's how you factor the difference of two squares. So now you can see that we have y plus 5 on the top and y plus 5 on the bottom, so you just cancel those out. And then multiply straight across. 6 times 1 is 6. And 11 times y minus 5 is 11y minus 55. So if you got that answer, good job. So now try 22, and when you come back, we'll do it together. All right, we're back. And we'll factor the difference of two squares. What number times itself is 9? That's 3, obviously, and put your plus and minus. For difference of two squares, it's always plus and minus. And you can see we have a common factor. Just cancel those out. And we're left with 8y minus 24. Actually, well, I guess I can use that. I can just distribute, and 2 times 1 is 2. So you can leave this in factored form and then reduce in the factored form like I did in previous problems, but you can also just recognize that you're taking a polynomial and dividing by a monomial. We actually learned how to do that in one of the first classes of this course, the class on polynomials. So we learned how to add and subtract polynomials and multiply and divide polynomials. So when you divide a polynomial by a monomial, you just divide each term. So 8y divided by 2 is 4y. And 24 divided by 2 is negative 12. So that's just one way to do it. But I just want you to be aware that you can keep it in the factored form, 8 times y minus 3 over 2, and then you can just factor this to 4. And then you can distribute to get 4y minus 12. That's another way to do it, which is the same thing we got. So if you got 4y minus 12, good job. So in this problem, we actually ended up with, we didn't have a fraction at the very end. All right, so that's when you have a fraction or multiple fractions within other fractions. But notice that in all the previous problems, we had one fraction in the top and one fraction in the bottom. Well, in the next problems, we're going to have more than one fraction in the top or the bottom. So in this case, we have two fractions in the top that we're adding and one fraction in the bottom. So in this case, what you have to do is you have to convert, or you have to simplify this complex fraction so that you only have one fraction in the numerator and one fraction in the denominator. So what we're going to do is we're going to combine these fractions, and that'll give us one fraction in the numerator and one fraction in the denominator, and it just becomes the same problems that we were doing before. So 3/4 plus 1/6. So I'm going to multiply both sides of this fraction by 3 to get 9 over 12, and both sides of this fraction by 2 to get 2 over 12. And you can see that we have common denominators now. And so now we can add those fractions in the numerator. 9/12 plus 2/12 is 11/12. So now we have the same problem that we had before. So that's all we have to do for these particular types of problems. So now we just switch to the older division symbol, just as we did in the previous problems. Now we get 66 over 60, which reduces to, divide both sides by 6, and you get 11 over 10, and that's the final answer. So again, the only difference between this problem and the previous problems we were doing is we have to combine these fractions first. So why don't you try 24, and when you come back, we'll do it together. All right, we're back. So I'm going to multiply both sides of this fraction by 2 to get 14 over 50. Now I have a common denominator in the numerators. So 14 over 50 plus 11 over 50 is 25 over 50. And now it just becomes the same type of problem we were doing before, but we probably want to reduce this fraction first. Why would we want to deal with those big numbers if we can reduce that fraction? And we can reduce that fraction. It's pretty easy, because I know that 25 goes into 50 2 times, so that means I can divide both sides of this fraction by 25, and 25 divided by 25 is 1, and 50 divided by 25 is 2. Now, if you didn't do that, that's okay. It's just something that's going to make things a lot easier. If you didn't do that, you just get bigger numbers you'd have to deal with at the end of the problem. One times 10 is 10. 2 times 3 is 6. Divide both sides by 2, and you get 5 over 3. So if you got 5 over 3, good job. All right, same situation, but now we have subtraction. No big deal. Get a common denominator, combine these fractions, and proceed as usual. Try 25, and when you come back, we'll do it together. All right, we're back. Multiply both sides of this fraction by 2, and you get 2, whoops. Multiply both sides of this fraction by 3, not 2, and you get 3 over 6. And now we have a common denominator in the denominators, or the denominator of the overall fraction. 5/6 minus 3/6 is 2/6. But I'm going to go ahead and reduce this before we proceed. And that reduces to 1/3, because we're dividing both sides of that fraction by 2, using the fundamental principle of fractions. So now we have 2/3 divided by 1/3, and we're going to flip, change the multiplication, and 2 times 3 is 6, and 3 times 1 is 3. But I just want you to know that we could just cancel these 3's out immediately. That's another way to do it. But I'm trying my best not to jump forward or confuse you. Now 6 over 3, divide both sides by 3, and you get 2 over 1, which is just 2. So if you got that answer, good job. All right, try number 26, and when you come back, we'll do it together. All right, we're back. Multiply both sides of this fraction by 4 to get a common denominator. Five twelfths minus 4 twelfths is 1/12. multiply straight across. 5 times 12 is 60. 6 times 1 is 6. Divide both sides of this fraction, or you can also just consider the fraction sign to be division. 60 divided by 6 is 10. There's a lot of different ways to think about this. So if you got 10, good job. So try number 27 is a little bit different because now we have to combine fractions in the numerator and we have to combine fractions in the denominator. So just be aware of that. You have to combine these and you have to combine these. So there's only one fraction in the numerator and one fraction in the denominator. That's what we want. Again, that's the goal. We have to combine, so we have one fraction in the numerator and one fraction in the denominator. We don't have one fraction in the numerator right now. We have two fractions. We don't have one fraction in the denominator or the numerator. So we have to combine those. So try 27. When you come back, we'll do it together. All right, we're back. So multiply both sides of this fraction by 4. Multiply both sides of this fraction by 3. Now we have a common denominator in the numerator. Multiply both sides of this fraction by 3. Multiply both sides of this fraction by 2. And now we have a common denominator in the denominator. All right. So now we're going to combine. So 4 24ths minus 15 24ths is negative 11 24ths. And 3 6 minus 2 6 is 1 6th. And now we just change to the old division symbol. Multiply straight across. 6 times 11 is 66. And 24 times 1 is 24. Let's shrink this stuff a little bit. Whoops. So now we need to reduce this fraction. If we divide both sides by 6, then we have 11 over 4. So negative 11 over 4. So if you got that answer, good job. Try number 28. When you come back, we'll do it together. All right, we're back. So multiply both sides of 3/4 by 2 to get 6 over 8. Now we have a common denominator in the numerator. And multiply both sides of 1/2 by 5 to get 5/10. And combine the fractions in the numerator. Combine the fractions in the denominator. And let's see here. We can reduce, but I'm just gonna go straight to the old division symbols and worry about reducing later on. And change to multiplication. Flip the divisor. And now I'm going to go ahead and reduce. So 10 over 4, that becomes 5 over 2, dividing both sides by 2 using the fundamental principle of fractions. And now we just multiply straight across. 5 times 11 is 55. 8 times 2 is 16, and you cannot reduce that. And a positive times a negative is a negative. So if you got that answer, good job. All right, so now we have the same situation where we have two fractions in the numerator and two fractions in the denominator. But now we have x's involved. We have variables. So we have to We have to use the principles that we learned in the class on adding and subtracting algebraic fractions. But again, we have to get a common denominator like usual. So I'm going to multiply both sides of this fraction by 2 to get 2 over 8x. And I'm going to multiply both sides of this fraction by x to get 5x over 8x. Now we have a common denominator. I'm going to multiply both sides of this fraction by 2x squared. So 2x squared times 1 is just 2x squared. And 2x squared times 2 is 4x squared. And I don't have to do anything with the other fraction. So you see we have common denominators in the numerator and the denominator. So now we can combine the expressions in the numerator. So we get 2 plus 5x over 8x. And in the bottom, 2x squared minus 1 over 4x squared. So now we have one fraction in the numerator and one fraction in the denominator. Again, the first problems that we didn't have multiple fractions in the numerator and multiple fractions in the denominator. We just had one fraction in the numerator, one fraction in the denominator. But in these problems, we have to combine the fractions in the denominator and numerator first, then it converts to the problems they were doing at the beginning of the class. All right, so now we just change to the old division symbol. And what I'm going to do here is I'm just going to multiply straight across and keep everything in factored form for now. And it's traditional to write the monomial first, so I'm going to go ahead and do that. We could factor out, cancel some of the x's, but I'm not going to do that here. So these are the things that we can reduce or cancel. So divide both 4 and 8 by 4. So 4 divided by 4 is 1. And 8 divided by 4 is 2. So we end up with 2 in the denominator. And we can subtract these powers. 2 minus 1 is 1. So we have 1x in the top. And we could write our 1 here, but we don't really need to. And everything else we just have to rewrite. We can't really reduce anything else. Now again, I did this differently. In the previous problems, I just reduced those x's immediately, and these numbers I just multiplied straight across. There's different orders that you can do this stuff. You have to get rid of or get used to doing things differently sometimes, because you're going to see other teachers do things differently, so you don't want to get confused. All right, so if you got, well, I guess we did that one together. All right, so now you can try number 30, and when you come back, we'll do it together. All right, we're back. Multiply both sides of this fraction by 3x to the fifth. And multiply both sides of this fraction by x. And multiply both sides of this fraction by 3. And how do I know to do that? Well, because it gives us a common denominator. Now because we have a common denominator, we can go ahead and start to combine. I think I'm going to need a little more room here. So we have 1 minus 6x to the fifth over 9x to the fifth, so on and so forth. And now, of course, we just follow the same algorithm. Looks like I'm going to have to shrink some of this stuff. I guess I'll just go off the page. Put a little arrow there. Actually, I think I'm going to try to shrink some of this stuff to save room. Whoops, that should be 9x to the fifth. All right. So now I'm going to go ahead and cancel these 9s immediately, and the x squared and the x to the fifth are going to subtract the powers. So 5 minus 2 is 3, and the 3 x's are going to end up in the bottom. And please understand that you cannot reduce these x's because they're part of a difference of two terms. So here we're going to have nothing left on the top, so I'm just going to do 1 minus 6x to the fifth times 1, which just be 1 minus 6x to the fifth. And the bottom, again, the 9 disappears, and I'm just left with 3 x's, so x to the third times 7x minus 6. And in the textbook, you're probably going to see this expanded or distributed. So distribute. X cubed times 7x is 7x to the fourth. And x cubed times negative 6 is negative 6x cubed. And there you go. Again, we cannot reduce these x's because the 1 is here, and it's a difference. Now, if the 1 were not here and it was just negative 6x to the fifth, then we could factor out a greatest common factor here, and we could reduce. But because that 1 is there, we can't do that. All right, so double checking everything. Everything looks correct. All right. So we got number 30 right. Good job. All right, so we're getting more complicated here. So now we have two fractions in the denominator. But you can see that we have a quadratic expression. So the first thing we're going to do is factor that quadratic expression. Again, we're factoring this quadratic expression. We know how to do that. We've done it a million times. What two numbers multiply to -6 and add up to +1? All right, so we factored, and you're probably thinking, okay, well, what did that do for us? Well, again, we have to combine these fractions. We have to have one fraction in the numerator and one fraction in the denominator. We don't have one fraction in the denominator. We do have one fraction in the numerator, but we have two fractions in the denominator. So we have to take those two fractions and combine them into one. But we can't combine them into one unless we get a common denominator. And it's easier for us to see a common denominator if we factor that denominator, the quadratic expression. So now all we have to do is multiply both sides of this fraction by y minus 2. And why are we doing that? Well, we're doing it because we now have a common denominator. And again, this is the fundamental principle of fractions. You can multiply both sides of the fraction by the same thing. In this case, we're multiplying both sides of the fraction by y minus 2. That's legal. Unless this is a 0, you can't do that. But we haven't talked about that in this in my math curriculum yet. All right. So now I'm going to go ahead and distribute this. Seven times y minus 2. Using the distributive rule, we have 7y minus 14. And I'm going to move this stuff over a little bit. So now we have a common denominator. We can add these up. So add the numerators. And now it just becomes division. And as you can see, we're going down instead of going up. No big deal. It's kind of hard to keep everything in the page here, so sorry about that. So now it just becomes 8 over y minus 2 divided by 7y minus 9 over y plus 3 times y minus 2. So as usual, we just change to multiplication. And you can see what's going to happen here. We have something that's going to cancel out. Seems like most of my problems are always canceling out. Like so. Not much canceling here. But it would be the same thing if you could cancel out these terms. Alright, so we're going to cancel out the y minus 2 and just treat the blue part as a factor of 1. Now 8 times y plus 3 is 8y plus 24. And 7y minus 9 times 1 would just be 7y minus 9. Multiplying by 1 doesn't change anything. So, as you can see, this really complicated expression simplified all the way to 8y plus 24 over 7y minus 9. That's the power of simplifying complex fractions. Now, you're probably thinking to yourself, that was a lot of work. I mean, we needed a whole page just to do one problem. Well, there's actually simpler ways to do this. The problem is I can't show you the simpler way, because if I show you this, the simpler way, well, the reason it is this a simple way is because it actually skips a lot of steps. But if I skip steps, you won't understand how to do the problem. So I can't show you the fast way. So we have to do it this long way, unfortunately. Now, if you want to skip some steps, that's okay. You can. But you have to get the right answer. So if you don't understand what's going on here and you skip steps and you do something wrong, then it's going to be a problem. So you can try skipping steps if you want to. That's perfectly fine. But if something goes wrong, you got to go back and you got to write every step out, because that's the only way to figure out what you did wrong. All right, so on to number 32. So we're going to factor anything in the denominator that we can, and obviously we have a quadratic here, so we should be able to factor that. What two numbers multiply to negative 20 and add up to negative 8? That will be negative 10 and positive 2. Now we have to combine these fractions, and I guess we didn't really have to factor in the first step on that quadratic, but we're going to factor it anyway, so we might as well just do it in the first step, I guess. All right, so now we're going to multiply both sides of this fraction, because again, we have to combine these fractions, but we can't do that unless we have a common denominator. So we have to multiply both sides of this fraction by y plus 2 and both sides of this fraction by y minus 10. So I'm going to copy that. So multiply both sides of this fraction by y plus 2. And please put your y minus 10 in parentheses and your y plus 2 in parentheses. Probably safe just to put everything in parentheses. All right. And I should probably extend that out a little bit. And make sure that your overall fraction is bigger. Make sure that this fraction line is bigger than the other fraction lines, or else it's going to look really weird. All right, so multiplying straight across, 5 times y minus 10 is 5y minus 50. And 7 times y plus 2 is 7y plus 14. So now we have a common denominator, and we can add the fractions in the overall denominator. So 5y plus, well, let's go ahead and rewrite this top fraction first. (5y plus 7y) is 12y. Negative 50 plus 14 would be negative, let's see here, negative 36, I believe. And let's see here. All right. So now we have one fraction in the numerator and one fraction in the denominator. So that tells us that we're ready to change to the old division sign. Change to multiplication, flip the divisor. And And you can see that we have a lot of different common factors here. So we can cancel out the y minus 10s and the y plus 2s. I'm going to use different colors there. And we get 8 times 1 is 8, and 12y minus 36 times 1 is 12y minus 36. Now this is an unusual situation because it just so happens that we can actually reduce this. This is the part where students really get into trouble, because you're going to look in the back of the book for the answer to check your answer, and you're not going to see this. And the reason for that is we can divide both sides of this by 4. So one way to do it is to factor out a 4. Actually, we can factor out a 12 from the denominator, and you can reduce it to 8 over 12. That's one way to do it. Probably the easiest way to do it, though, is just use the fundamental principle of fractions and divide both sides of the fraction by 4, like I said. So 8 divided by 4 is 2. And you're probably thinking, whoa, we don't know how to divide this by 2. Well, actually, yes, you do. We learned how to do that in the class on polynomials. You can divide a polynomial by a monomial. So 12y minus 6 divided by 2, you just divide each term by 2. So that would be 6y minus 18. Excuse me, we should divide both sides by divide it by 4. We divided the numerator by 4, so we have to divide the denominator by 4. So that would be 3y minus 9. And that would be our final answer. All right. So just double checking that. Everything looks good. So now we have the same situation here. But instead of a quadratic, we're just going to be factoring out a common monomial here. So you can do this problem, and when you come back, we'll do it together. All right, we're back. Factor out z. And again, we didn't really need to factor in the first step, but now we're going to multiply both. We're going to combine these fractions, so multiply both sides of this fraction by z minus 6, and multiply both sides of this fraction by z. And now we have a common, well, let's go ahead and multiply first. 3 times z minus 6 is 3z minus 18. Z times 1 is z. And now we have a common denominator, so we can go ahead and combine those. And we're subtracting. This is a positive z, but it becomes negative because we're subtracting this fraction. So it's not going to be 3z plus z, it's going to be 3z minus z, which would be 2z, and then you just rewrite the negative 18. This negative has nothing, it is not going to change this negative 18 because you're not subtracting this fraction. You're subtracting this fraction. And that's over z times z minus 6. So we combine the fractions in the numerator. And so now we have one fraction in the numerator and one fraction in the denominator. So now we're ready to change to the old division symbol. And of course we can just cancel out and multiply straight across, and we get 2z minus 18 over 7. So if you got that answer, good job. If you didn't get that answer, that's not unusual because these problems are pretty long. So just go back and figure out what you did wrong. So that's all the work there. All right, on to number 34. If you didn't get 33 right, that's okay. You'll have a chance to redeem yourself in 34. Just try 34, and when you're done, we'll do it together. All right, we're back. And I guess we'll just go ahead and factor out. So now, all we have to do is multiply both sides of this fraction by z minus 2. So I'm going to copy this so I don't have to rewrite it. So multiply both sides of this fraction by z minus 2, and it doesn't matter which side you write it as long as you have space. And let's see here, so that's going to be 4 times z minus 2 is 4z minus 8. And it's common to write the monomial on the very left. And so now we have a common denominator in the numerators, so we're ready to combine. And again, this is negative 8 minus 2, not plus 2, minus 2, because you're subtracting. So we're left with 4z. Negative 8 minus 2 is negative 10. And now we change to the old division symbol. And we could factor something out of here, but it wouldn't really help anything, so I'm not going to do that. So now we can reduce z minus 2 and z minus 2 cancel out. And 4z minus 10 times 1 is just 4z minus 10. Again, the highlighted parts can just be considered to be 1 because they disappear. And 1 is always a factor. And z times 3 is 3z. And it's customary to write the normal number before the letter. So if you got that answer, good job. All right, on to number 35. Number 35, we have the same situation except you have the difference 2 squares. You know how to factor the difference 2 squares. We've done that a million times. And you're going to the difference between this problem and the other problems is, let me check here. Actually, I guess we did do that in the. Actually, no, we didn't. So we do have a difference here. The difference is we have to combine fractions in the numerator and the denominator. So maybe we'll try this one together. So I'm going to factor the difference 2 squares. And again, you've done that a million times. So don't say that you have no clue how to do it. If you forgot, that's okay, but this should refresh your memory right here. What number multiplies to itself to get 49, and you have your plus and minus. So all I did on the first step was just factor that one expression. That's it. I'm taking it slow. Alright, so now that allows us to see how to get the lowest common denominator in algebraic terms. So I'm going to go ahead and copy this so I don't want to have to rewrite it again. And then I'm going to try to get a common denominator. So I'm going to multiply both sides of this fraction by x minus 7. And please put the x plus 7 in parentheses. Multiply both sides of this fraction by x plus 7. And why am I doing this? Because it's just going to give us a common denominator in algebraic terms. And I'm going to multiply both sides of this fraction by x minus 7. And I don't have to do anything to this fraction because I already have x minus 7 times x plus 7. Alright, so now we're going to multiply, distribute 2 times x minus 7 is 2x minus 14. And 7 times x plus 7 is 7x plus 49. Eight times x minus 7 is 8x minus 56. So I'm just going to double check that. Everything looks right. Remember, in algebra, if you make one mistake, the answer is going to be wrong. So now we have common denominators in the top and the bottom. So we can combine the top. 2x minus 14 plus 5 is 2x minus 9. Whoops. And combine the fractions in the denominator. 7x plus 8x is 15x. And 49 plus negative 56. Now we don't have to change the signs here because we're adding the fraction. If we were subtracting, if this were a subtraction sign, then we'd have to change this positive 8x to a negative 8x and this negative 56 to a positive 56. But we don't have to change the signs here. So that 49 plus negative 56 would give us negative 7. And now we have one fraction in the numerator and one fraction in the denominator. So things are becoming simpler. So now we need to change to the old division symbol. Do we have to change the old division symbol? Not really. There's a faster way to do it, but the faster way is harder to understand. It skips steps. So we're not going to do that today. Again, you're probably thinking, well, you know, you're insane. You're insane to do this. This takes too long. It's too frustrating. I don't want to do this. It's boring and horrible, and why are you doing this? Well, again, there's a faster way to do it. I can get from here to here in about maybe about 8 or 9 seconds, but I can't do it that way because it's going to skip too many steps, and you're not going to understand what's going on. But just be aware that when you start to get the hang of this, you can start to skip steps. But don't skip steps too early because you're not going to know what's going on. All right, so we can cancel out. Whoops, I should probably use different colors for each one. Cancel those out. Cancel these out. So again, the highlighted parts you can just consider to be 1. So now we multiply straight across. Multiply the numerators. 2x minus 9 times 1 is just 2x minus 9. And 15x minus 7 times 1 is 15x minus 7. And you might think that this fraction is still somewhat complicated, but it's nowhere near as complicated as this fraction up here. All right, so we did that one together. Let's see if you can do 36. Try 36, and when you're done, we'll do it together. All right, we're back. Factor the difference of two squares. And so all I did was factor in that first step. I'm going to copy this so I don't have to rewrite it. So now we're going to find a common denominator. Multiply here, we get 8x minus 48. And again, if this were a negative, then you would have to change these signs. Be aware of that when you're doing practice problems in your homework. If this is a negative, you have to change these signs when you combine. So now we've got a common denominator, and we're ready to combine. So 2x plus 5x in the very top is going to be 7x. 12 plus negative 30 is negative 18. And we just have 8x, and 7 plus negative 48 is negative 41. So now we have one fraction in the numerator, one fraction in the denominator, so we're ready to change to the old division sign, or the old division symbol. Cancel out as usual. I'm going to use a different color this time. 7x minus 18 times 1 is 7x minus 18, so on and so forth. Again, you can just consider the colored parts to be 1. So 1 times 7x minus 18 is 7x minus 18. 1 times 8x minus 41 is 8x minus 41. So if you got that answer, good job. All right, on to number 37. So again, we're going to factor. So why don't you try this problem, and when you come back, we'll do it together. All right, we're back. There we go. All right, and now we have common denominators, so we can combine the fractions. 5y minus 13 over y minus 3 times y minus 8. So on and so forth. All right, so we can cancel out. Anything on the top and the bottom can be canceled out, and 5y minus 3 times 1 is 5y minus 3, and 6y minus 28 is 6y minus 28 times 1 is 6y minus 28, obviously. Again, the highlighted portions are just 1. All right, so if you got that answer, good job. So I'm going to go ahead and put a negative here just to demonstrate to you that, that subtraction principle. So go ahead and try 38, and when you come back, we'll do it together. All right, we're back. Get a common denominator. All right, let's move this over a little bit. So now we have common denominators, but we have to be careful about these signs here. So first let's add the numerator fractions. Y plus negative 3y is negative 2y. 4 plus 6 is 10. And here's where we have to be careful. It's not going to be 2 minus 12. It's going to be 2 plus 12. Because you're subtracting, so you're going to change these signs. So 2 plus 12. Again, this is a huge source of potential error. And this is not going to be a positive 6y. It's going to be negative 6y. And so that would be 2 plus 12 is 14. And as usual, we're going to cancel out. Whoops. I'm going to do different colors for each factor. Should have done different colors for each factor here. I forgot about that. Well, it doesn't really matter. All right, so now we get negative 2y plus 10 over negative 6y plus 14. But unfortunately, there's one more thing we can do. Don't get mad at me. But there is one more thing that we can do. We can divide both sides of the fraction by 2. And when you divide a polynomial by 2, you just divide each term by 2. So that would be negative 2y. Negative 2y divided by 2 is negative y. And 10 divided by 2 is 5. Negative 6y divided by 2 is negative 3y. And 14 divided by 2 is 7. So that is going to be the final answer. Now, if you multiply both sides by negative 1, using the distributive rule, you end up with y minus 5 over 3y minus 7. That's another way that you might see the answer. So we'll just write or. Sometimes textbooks will take this and they'll change it into that, thinking that they did you a service, but really they're just going to confuse you there. So just be careful about that. Again, they just use the fundamental principle of fractions to multiply both sides of this fraction here by negative 1, and that changed all the signs. So either answer would be correct. Let me just double check all that. Everything looks good. All right, so if you got those answers, or one of those answers, good job. So just in case I don't get to these last problems, I'm going to try these last problems first. So the difference here is we have a whole number in the numerator. You don't have to have fractions in both the numerator and the denominator in order for it to be a complex fraction. You just have to have one fraction within a fraction. So here we have a whole number in the numerator and a fraction in the denominator. So I just want to show you how to do that problem. It's still going to be the numerator divided by the denominator as usual. It's this number divided by this number. But at this point, you might be thinking, well, how do we do this? You might not recall how to do that from the previous class. Well, you just write, this is a whole number, so you just write the whole number as over 1. And that just becomes the same type of problem. So division becomes multiplication. Multiply straight across, and you get 8 over 3. So I just want you to be aware of that. So why don't you try 48? When you come back, we'll do it together. All right, we're back. Negative 5, 6 divided by 8. And that just becomes divided by 8 over 1. just flip and change the multiplication. Multiply straight across and you get negative 5 over 48, and you cannot reduce that. So if you got that answer, good job. So let's try one with variables. 6x divided by 3x over 2. And again, that's a whole number term, or it appears to be a whole number term, so you just write 6x over 1. Change the multiplication, flip, and you can use parentheses for multiplication if you want. 6x times 2 is 12x. 1 times 3x, 1 times 3x is 3x, but we can reduce that. So that's going to, the x's are just going to cancel out because they have the same power. And 12 divided by 3 is 4. So we got 4. Well, we did that one together, so. All right, now you try number 50, and when you come back, we'll do it together. All right, we're back. Now you got to put parentheses because you're not allowed to put a division sign with a negative sign right next to each other without parentheses. Why? Well, that's just algebra notation. Don't ask me why. I don't know. It's just algebra. It's like using it's like asking why do we use the word the? I don't know. It's just the English language. All right. So again, we're going to write negative 7y over 1. And multiply straight across, and we get 2y over 35y. And the y's just cancel out. And you're left with negative 2 over 35. So if you got negative 2 over 35, good job. All right, so I just wanted to get to those last problems in case we didn't finish on time. So I'm kind of just jumping around here. Let's do number 41. The difference here is we have whole numbers. We didn't have whole numbers before. So let's see what happens. We have to get a common denominator. Obviously, the common denominator is just x plus 1. So what we're going to do is what we just did in the previous problems. We're going to write these whole numbers as over 1 so we can interpret them as fractions. And it'll be easier for us to see what's happening because, again, they're whole number terms. So we can just write over 1, and now these look like fractions. All right, so now, again, we want a common denominator of x plus 1. So we're going to use the fundamental principle of fractions to get a common denominator. So I'm going to multiply both sides of this fraction by x plus 1, both sides of this fraction by x plus 1, both sides of this fraction by x plus 1. Again, just using the fundamental principle of fractions. And we get 3x plus 3 over x plus 1 x plus 1 over x plus 1. So again, 3 times x plus 1 is 3x plus 3. 1 times x plus 1 is x plus 1. And so on and so forth. So now we have a common denominator. So we can combine. So 3x plus 3 plus 2 is 3x plus 5. And x plus 1 minus 3 is x minus 2. So let's just double check that. Everything looks right. Cancel out the common factors, and we're just left with 3x plus 5 over x minus 2, because again, those highlighted parts are considered to be 1. All right, so let's see here. We don't have time to do 42, but we'll do 43. So we have whole number terms, what appear to be whole number terms. So we have to write those whole number terms as over 1. Just like we did in the previous problem. So now they look like fractions, and we can just deal with them the same way we dealt with all the other problems. So now we're going to multiply both sides of this fraction by a plus 2. Both sides of this fraction by a plus 2. And why are we doing that? Well, because it gives us the common denominator. Now we're gonna, let me change that, make that power a little more legible. A squared times a plus 2 is a cubed plus 2a squared. Five a times a plus 2 is 5a squared plus 10a. Just double checking everything. Again, you make one mistake in algebra and the whole thing is going to be wrong. So now we have a common denominator. Do you see all these common denominators? That's why we did that. Now we can combine the numerators and the denominators. So be very careful because we have subtraction signs here, which means you're going to have to change the signs in all these terms. The a cubed term. Change all the signs here. They're positive and then they're going to become negative. So you're going to get a minus a cubed minus 2a squared. This is a positive, this is a positive, but they both become negative because you're subtracting that entire fraction. Just waiting for my computer to catch up here. Now you cannot combine those because they're unlike terms. They have different powers. Remember, you can't combine variables when they have different powers, unless you're multiplying, of course. And then that would be minus 3, of course. All right, moving right along. Just double checking everything. And as you can see, we can cancel out. And this is not a quadratic. This is a quadratic, so we could factor this to see if there's something else will cancel out, but I know I know nothing's going to cancel out because this is not a quadratic. Actually, technically it would be a quadratic if I factored out an a, but it's not going to be the same quadratic as this expression, so you don't have to worry about that. So multiply straight across, and we have the following answer. So that's how you would solve that type of problem. So we don't have time to do another one. I'm sorry, we're just running out of time in this class. We have limited time, so we can't just keep going on and on and on. Let's see here. So I'm going to try to do one more problem if I have time. So factor the quadratic. And do O and I of FOIL. 6y plus 2y is 8y, so that works. And they're going to write 9 over 1. We must write 9 over 1. We have a whole number. That's the difference with these problems, is we have a whole number. So that's what's different about this problem. So we just write 9 over 1. And if we don't have time to finish, just remember that, well, we're going to have to finish this problem. All right, so again, I wrote 9 over 1, and I factored what I could factor. And so now we're proceeding just like normal. So now I'm going to multiply both sides of this fraction by 3y plus 2. And both sides of this fraction by 3y plus 2. And this is where things get tricky. This is going to be the hardest problem in this class. I'm going to have to multiply both sides by both binomials. This problem may be a little more difficult than some teachers would even try to attempt. But I just want you to see one of these problems. See, I need this denominator. I need it. I have to have a common denominator. So I have to multiply by that whole thing in order to get that in the denominator of this whole number term. All right, so as usual, distribute. We get 6y plus 4. Whoops, now we have minus. And in the bottom, that's easy. We're just going to end up with 3y plus 2 times y plus 2. Put in the, and let's save this. That's the hard part. So let's save that to the end. So 3y plus 2 times 1 is 3y plus 2. And so now we're going to multiply, but we have to distribute. We have to do all kinds of stuff here. So first thing we're going to do is we're going to go ahead and FOIL this out. We have to FOIL it out. Unfortunately, we can't combine these terms unless we FOIL that. So I'm not going to multiply by the 9 yet. I'm just going to FOIL it out. So 3y times y is 3y squared. O is 6y and I is 2y. Add them up and you get 8y. And I don't need to do this, because I know it's going to be 3y squared plus 8y plus 4. So I could just change it to that immediately, but in fact, that's actually the smarter thing to do. And so I just put it back into that form. Then I'm going to multiply it by 9, and we use distribution. I should probably put parentheses around the 9. So distribute to all these terms. Whoops, that should be a minus. So then we get 27y squared plus 72y plus 36. Everything looks right. So now we have common denominators, so we can just combine the fractions in the numerator. And combine the fractions in the denominator. (72y plus 3y is 75y. Again, you can only combine like terms. You can't combine the y squared with the normal y's. And 36 plus 2 is 38. And then it just becomes, got to go to the old division sign. All right. Proceeding as usual. Nothing different at this point. And now we just cancel out. Multiply 6y minus 1 times 1 is 6y minus 1. And multiply the bottom by 1, you get 27y squared plus 75y plus 38. And that's our final answer. Again, the highlighted parts are considered to be just 1 because 1 is always a factor. So I'm sorry we didn't have time to do more problems. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. Don't go before you get your homework. Get a screenshot of these first 2 pages. And screenshot number 2. And screenshot number 3. Be sure to do that homework completely, correctly, neatly, and put it in order in your binder. And remember, if you don't do the homework, it's 100% guarantee that you're not going to achieve the objective of this course, which is fluency in algebra. So get that homework done, and I look forward to seeing you in the next class.